Welcome back, explorer. Pull your blanket a little closer. Set your phone face down on the nightstand. Let your shoulders fall. Let the tension in your jaw just go. You're here. You made it through the day. And tonight, we're going somewhere extraordinary. Not to a distant galaxy. Not to a war, or a kingdom, or the halls of power. Tonight, we're going somewhere much older than all of that. Much quieter. Much stranger. Tonight, we are going underground. Into the soft, dark, breathing world beneath your feet. Into the kingdom that has no king. Into the oldest living network on this earth. Tonight, we are going to explore the world of mushrooms. Now, I know what you might be thinking. Mushrooms? Really? But stay with me, explorer. Stay with me. Because by the time this journey is over, you will never look at a forest floor the same way again. You will never walk across a field without wondering what is happening beneath your shoes. You will never glance at a small brown cap pushing through the soil without feeling, in the deepest part of you, a sense of awe. Because mushrooms are not just fungi. They are not just a topping on your pizza, or a quiet ingredient in a soup. Mushrooms are ancient. They are intelligent, in a way that defies our usual understanding of that word. They are generous. They are mysterious. And in many ways, they are the reason that you and I are alive at all. So get comfortable. Close your eyes if you'd like. And let me take you on a journey, back to the very beginning of life on land. Back to a time before trees. Before flowers. Before insects, or birds, or anything with a spine. Back to the first, brave, quiet pioneers of the living world. Back to the fungi. Music swells gently, then settles into a slow, breathing rhythm. I'm your guide on the Midnight Explorer. And tonight, we explore together. Close your eyes for a moment. Picture a world with no color. Not dark, just colorless. Gray and brown and the pale, endless blue of an ancient sky that has never been reflected in a human eye. The year is approximately 1.3 billion years ago. The oceans are warm and shallow in some places. Deep and cold in others. And in those oceans, life is doing something incredible. Life is figuring itself out. Single-celled organisms drift in the water. Some of them eat sunlight. Some of them eat each other. And somewhere, in the warm shallows of an ancient sea, a cell does something no cell has quite done before. It forms a partnership. Not an accident. Not a collision. A quiet, slow, deliberate agreement. One cell begins to feed another. One cell begins to provide shelter to another. And in return, something new is born. This is, according to many scientists, the moment when fungi and animals, you and I, begin our separate journeys. Because here is one of the most astonishing facts you will learn tonight. You are more closely related to a mushroom than a mushroom is to a plant. Let that settle in. A mushroom, that small, quiet, soft thing pushing through the earth, shares more genetic ancestry with you than it does with the oak tree it grows beside. Fungi are not plants. They are not animals. They are their own kingdom. Their own story. Their own ancient, patient civilization. The scientific kingdom is called fungi. And it has been here, in one form or another, for somewhere between 1.3 and 1.5 billion years. To understand how long that is, think of it this way. The dinosaurs appeared roughly 230 million years ago. They were wiped out around 66 million years ago. Fungi had already been alive for over 1 billion years before the first dinosaur ever drew breath. They watched the dinosaurs rise. They watched them fall. They watched the mammals scurry out from hiding. They watched the primates climb down from the trees. They watched us stand upright, stare at the stars, and start asking questions. And through all of it, through every mass extinction, every ice age, every volcanic winter, the fungi endured. They are, in the truest sense of the word, the survivors. Now, let's walk a little further back in time. About 470 million years ago, something remarkable was beginning to happen on Earth. Life was starting, slowly, tentatively, nervously, to come ashore. The land was not welcoming. There was no soil, not really. Not the rich, dark, crumbling earth we know today. There were only rocks. Ancient, bare, volcanic rocks. Cracked by heat, scoured by wind, soaked occasionally by rain that had no idea what to do with itself once it hit the ground. There was no shelter. There was no nutrition. There were no roots. And yet something decided to try. The first organisms to truly colonize land were not plants. They were not animals. They were, according to many paleobiologists, a partnership between fungi and ancient photosynthetic organisms. A kind of living arrangement that still exists today, that we call lichen. Lichen. That gray-green, crusty, quietly beautiful thing you see growing on gravestones and old stone walls. Lichen is not a single organism. It is a marriage. A fungus and an algae, or sometimes a cyanobacterium, living so closely together that for centuries, scientists thought they were one thing. The algae provides food, sugar made from sunlight. The fungus provides structure, moisture retention, and the ability to cling to rock. Together, they do what neither could do alone. Together, they survive. And as they survived, as generations upon countless generations of this partnership lived and died on the bare rock of early Earth, something happened. They broke the rock down. Slowly, patiently, over millions of years, they dissolved it. Their acids bit into the mineral surface. Their bodies, when they died, left behind organic matter. They made soil. Fungi made the soil that would one day grow every plant, feed every animal, and nourish every civilization in the history of the world. Pause on that. The ground beneath every forest, every field, every garden that has ever produced food, that ground began with fungi. Before wheat could grow, fungi had to make the earth that wheat grows in. Before the grass could spread across the plains had to be built, grain of crumbled stone by grain, across geological ages, by fungi. The ground you walk on. The food you eat. The trees that gave early humans shelter. All of it, in a very real and profound sense, began with the quiet work of fungi. They didn't do it because they were heroic. They didn't do it with any awareness of what they were building. They simply did what life does. They spread, they fed, they grew, they died, and they left the world a little more hospitable than they found it. That is the first gift of fungi to our world. The gift of ground. Let me paint you a picture. You are standing at the edge of an old-growth forest. The kind of forest that has not been touched by a chainsaw or a road in centuries. The trees here are enormous. Their trunks as wide as small rooms, their canopies so dense that even at noon, the light filters down in soft, golden shafts, like something out of a cathedral. The air smells of rain, and bark, and something deeper, something earthy and green and ancient. At your feet, the forest floor is thick with moss and fallen leaves. Little mushrooms dot the earth here and there, some of them the size of a button, some the size of your palm. Some so small you might not see them unless you knelt down and looked. Now here is what I want you to imagine. Beneath your feet, beneath the moss and the leaves and the roots and the soil, there is a network. A network so vast, so intricate, so finely woven, that if you could hold 1 square meter of healthy forest soil in your hands, you would be holding more than 100 kilometers of fungal threads. 100 kilometers. In 1 square meter. These threads, called hyphae individually, and mycelium collectively, are the body of the fungus. What we see above ground, the mushroom, the cap, the gills, the stem, that is not the real fungus. The mushroom is just the fruit. The flower. The briefest expression of something vast and mostly hidden. The real fungus is below. It is the mycelium. And in a mature forest, it connects almost everything. Now here is where this story becomes truly extraordinary. Beginning in the 1990s, a forest ecologist named Suzanne Simard began conducting experiments in the forests of British Columbia, Canada. She was curious about a question that had long nagged at her: how did trees transfer carbon from one to another? What she found astonished the scientific world. Trees, through the mycelium, were feeding each other. She discovered that a large, old tree, she began calling these mother trees or hub trees, would send carbon. The fundamental stuff of life, through the fungal network to younger, smaller trees nearby, particularly to its own offspring growing in its shade. The mother tree would recognize, through chemical signals in the network, that her seedlings were struggling in the low light. And she would feed them. Through the web. Through the mycelium. Through the silent, underground network of fungi that connects every root to every root in the forest. She called it the Wood Wide Web. And the world fell in love with the idea. Because here was a forest that was not a collection of competing organisms, each fighting for sunlight and water and survival. Here was something more like a family. A community. A living network in which the old cared for the young, the healthy supported the struggling, and information, about drought, about insects, about disease, flowed continuously through the underground web, allowing the whole forest to respond, adapt, and survive together. Music softens further, becoming almost just a hum. Now, science being science, the picture is more complex than the popular telling of it. The relationship between trees and fungi is not pure altruism. It is not exactly love, in the way we understand love. It is a trade. The tree provides the fungus with sugars. Sweet, rich carbohydrates made from sunlight through photosynthesis. The fungus, in return, provides the tree with something the tree cannot easily get on its own: nutrients from the soil. Phosphorus. Nitrogen. Water. The fundamental building blocks that trees need to grow. This relationship, called mycorrhiza, from the Greek words for fungus and root, is one of the oldest and most successful partnerships in the history of life on Earth. About 90% of all plant species on Earth have mycorrhizal relationships with fungi. 90%. That means almost every plant you have ever seen, every tree, every flower, every blade of grass, is involved, underground, in this ancient, ongoing trade with the fungal world. The forests of the world are not made of trees. They are made of trees and fungi, so intertwined that to separate them would be to destroy both. When loggers clear a forest and the soil is left bare, it is not just the trees that die. The mycelial network dies too. And when the network dies, regrowth becomes dramatically harder, because the new seedlings have no web to plug into, no community to feed them, no underground infrastructure to support them. One of the reasons reforestation is so difficult in completely cleared land is precisely this: the web is gone. You can plant all the trees you want. But without the fungi, the forest cannot reconnect. This is why some conservationists have begun the painstaking work of reintroducing mycorrhizal fungi to degraded soils, essentially replanting the web before replanting the trees. It is slow work. It is quiet work. It is fungi's work. And slowly, when it succeeds, the forest begins to breathe again. I find myself thinking about this network often. About what it means that beneath the surface of the visible world, there is this other world, this slower, quieter, but no less real world, of connection. Of information. Of sharing. Of community. We tend to think of nature as a war, every creature fighting every other creature for resources, for survival, for dominance. And certainly, that is part of nature. Competition is real. Predation is real. But the forest, viewed through the lens of mycology, tells a different story. It tells a story of cooperation that is not an exception to evolution, but one of its deepest strategies. The trees that survived, the forests that endured ice ages and droughts and storms, did so not in isolation. They did so because they were connected. And perhaps that is a lesson worth carrying with you as you drift toward sleep tonight. That connection is not weakness. That sharing resources is not foolish. That the most resilient systems in nature, and perhaps in human life too, are the ones built not on individual strength alone, but on the strength of their web. Somewhere around 120,000 species of fungi have been formally identified and named by scientists. But that, in all likelihood, is only a fraction of what exists. Some estimates suggest there may be as many as 3.8 million species of fungi on Earth, the vast majority of which no human has ever seen, named, studied, or described. 3.8 million. To put that in perspective, we have identified roughly 8.7 million species of life on Earth in total, across all kingdoms. Fungi may represent nearly half of all life on Earth, and we have barely scratched the surface. They are, in the truest sense, still largely unknown. Still largely mysterious. Still largely unexplored. Which means that somewhere in an old-growth forest, or a deep ocean vent, or a tropical rainforest canopy, there are fungal species doing things we cannot yet imagine. Forming partnerships we have not yet described. Producing chemicals we have not yet discovered. Playing roles in ecosystems we do not yet understand. The frontier of fungal science is not behind us. It is ahead of us. It is vast and it is beckoning. But tonight, let us spend some time with the mushrooms we do know. Because even among the known, the variety is breathtaking. Let's begin with one of the most iconic, the Amanita muscaria. You know this one. The red cap with white spots. The mushroom from fairy tales. The one that Alice might have nibbled. The one painted on 1,000 greeting cards and illustrated in 1,000 children's books. It grows in birch and pine forests across the northern hemisphere, in Siberia, in Scandinavia, in the forests of North America. When you see it in autumn, rising from the leaf litter in its brilliant red coat, it looks almost like a decorative object, something placed there by an artist rather than grown by nature. And it has a history as rich and strange as its appearance. The Amanita muscaria is one of the oldest known psychoactive substances in human history. The Siberian shamanic traditions, some of the oldest continuous spiritual practices on Earth, used this mushroom in ceremony, in healing, in the crossing of boundaries between ordinary and non-ordinary reality. Reindeer, who live alongside these shamans in the frozen north, also eat the mushroom. They have been observed seeking it out deliberately, eating it enthusiastically, and then exhibiting behavior that can only be described as intoxicated, running, jumping, shaking their heads, moving in ways that the reindeer of an ordinary afternoon do not move. Some anthropologists have suggested that the image of flying reindeer, so central to our modern mythology of Christmas, may be rooted in this ancient observation of reindeer who had eaten the amanita and seemed, in the eyes of the shamans who watched them, to fly. The Santa Claus figure himself, the red and white clothing, the descent through the chimney, the night journey, may contain echoes of ancient Siberian shamanic traditions in which the red and white mushroom was a central character. Now, I am not saying this to collapse a beloved myth. I am saying it because it is beautiful. It is beautiful that a small mushroom growing in a frozen forest, thousands of years ago, might have woven itself into one of the most widely shared stories in the modern world. It is beautiful that fungi are there, quietly, in our oldest stories, in our deepest cultural memories, in our most cherished traditions. Even when we don't know they are there. Let's travel now to the Pacific Northwest. To a forest in eastern Oregon, near a town called Prairie City. Here, in the Malheur National Forest, lives the largest living organism on Earth. Its name is Armillaria astoi, the honey fungus. And it covers approximately 2,385 acres. That is about 3.7 square miles. Nearly the size of the entire island of Manhattan. It is, in terms of sheer physical extent, the biggest single organism that has ever been measured on this planet. Above ground, it is barely visible. Just occasional clusters of small, honey-colored mushrooms appearing in autumn among the pine trees. But underground, it is everything. Its mycelium threads run through the roots of the trees. It is not entirely benign, this particular species is partially parasitic, and the trees in this area show signs of the struggle. But this singular organism has been quietly spreading, slowly, through this forest for somewhere between 1,900 and 8,650 years. The estimate is wide because aging a fungal network is extraordinarily difficult. But even at its youngest estimate, this single organism is nearly 2,000 years old. It was alive when the Roman Empire was in full bloom. It was alive when the Great Wall of China was being built. It has been quietly, patiently, enormously alive through the entire span of recorded Western history. And most of us have never heard of it. Most of us walk past it, or above it, or through it, with no idea whatsoever. The greatest living being on Earth, and it goes about its existence in total obscurity. There is something about that which I find deeply, profoundly beautiful. Now let me tell you about some mushrooms that glow. Yes. Glow. In the forests of Brazil, in the dense, humid tropics, there are mushrooms that produce their own light. Bioluminescent fungi. About 80 species have been identified so far, produce a faint, greenish, otherworldly glow in complete darkness. If you were to walk through a forest where these fungi grow, on a moonless night, with your eyes adjusted to the dark, you would see the forest floor glowing softly. Small points and patches of green-blue light, scattered among the roots and the fallen branches. It would look like scattered stars. It would look like a dream. Nobody is entirely sure why they glow. The current best hypothesis is that the light attracts insects, which then carry fungal spores to new locations, a form of dispersal, using light instead of scent or color. But there is still much uncertainty. The fungi may know something we don't. They usually do. Let's visit one more before we move on. The cordyceps fungus. If the wood wide web is the gentle, cooperative face of the fungal world, cordyceps is its gothic, disturbing, astonishing other face. Cordyceps is a parasitic fungus. And its hosts are insects, particularly ants. Here is what happens. A cordyceps spore lands on an ant. It begins to grow, not just on the surface of the ant, but inside it. The fungal hyphae thread through the ant's body, gradually consuming it from the inside while keeping the ant alive and functional. And then, when the time is right, the fungus does something that still makes biologists pause. It hijacks the ant's nervous system. The ant, its behavior now controlled by the fungus, leaves its colony. It climbs, upward, always upward, to a specific height above the forest floor. Not too high. Not too low. Exactly the optimal height for spore dispersal. Then the ant bites down, hard, on a leaf or a stem. It locks its mandibles. And it dies. And from its body, from its head, often. The fruiting body of the cordyceps fungus erupts, releasing spores that will drift down to the forest floor below, to find more ants, to begin the cycle again. This has been happening for millions of years. A fossilized leaf, 48 million years old, has been found bearing the distinctive bite marks of a cordyceps-infected ant, locked in exactly the position that modern cordyceps victims are found in today. 48 million years. This fungus has been performing this extraordinary, disturbing, breathtaking act of biological manipulation for 48 million years. Long before there were humans to be disturbed by it. Long before there was language to describe it. Long before there was a word for parasite, or manipulation, or horror. It has just been quietly, efficiently, going about its work. Nature is not always gentle. Nature is not always peaceful. But it is always, always remarkable. Let me take you to London. The year is 1928. September. The end of summer. The air is warm and heavy, and the city smells of coal smoke and river water and the particular mustiness of old stone buildings in the heat. In a laboratory at St. Mary's Hospital, a Scottish bacteriologist named Alexander Fleming has returned from a holiday. He is a careful, curious man, the kind of scientist who notices things that other scientists might walk past. He sits down at his bench and begins sorting through the petri dishes he left before his vacation. In one dish, something has gone wrong. A mold has grown, unwanted, unintentional, and contaminated the bacterial culture he was studying. Any other scientist, on any other day, might have simply thrown the dish away. Contamination happens. It is frustrating, but it is normal. The dish goes in the bin, you start again. But Fleming looked. He looked at the mold. A blue-green penicillium mold, probably blown in through a window, and he noticed something. Around the mold, there was a circle of clear space. The bacteria were dead. Not just absent. Not just displaced. Dead. Something the mold was producing had killed them. Fleming leaned forward. He picked up the dish. He carried it to the window to look at it in better light. And in that moment, in that quiet, unhurried, curious act of looking more closely, the antibiotic age began. What Fleming had discovered, and what would take more than a decade of further work by Howard Florey and Ernst Boris Chain to develop into a usable medicine, was penicillin. The world's first antibiotic. A molecule produced by a fungus. A molecule that, when isolated and refined, could kill the bacterial infections that had been killing human beings since the dawn of our species. Pneumonia. Scarlet fever. Infected wounds. Syphilis. Blood poisoning. Diseases that had been essentially death sentences, diseases that had killed kings and peasants alike, that had swept through armies and wiped out families, suddenly became treatable. By the time World War II was ending, penicillin was being mass-produced and distributed to Allied forces. Soldiers who, in any previous war in history, would have died from infected wounds, walked away. The number of lives saved by penicillin is estimated at somewhere between 80 and 200 million. 200 million human lives. Because a scientist looked at a contaminated petri dish instead of throwing it away. Because a fungus, quietly going about its ancient business of competing with bacteria for food and space, had, entirely without knowing it, produced the most important medicine in human history. But penicillin is just the beginning of the story. Because fungi, it turns out, are extraordinary chemical factories. They have been locked in an arms race with bacteria for over 1 billion years. In that time, they have evolved a staggering array of chemical compounds, molecules designed to kill, to defend, to communicate, to attract, and to repel. And many of these compounds, when we discover and study them, turn out to be extraordinarily useful to us. Lovastatin, one of the first statin drugs, used to lower cholesterol and reduce the risk of heart disease, was derived from a fungus called Aspergillus terreus. Cyclosporin, the immunosuppressive drug that made organ transplantation possible, that allowed us to give new hearts and new livers and new kidneys to people who would otherwise have died, was derived from a fungus found in a soil sample from Norway. A soil sample. Someone, somewhere, collected a handful of soil. And in that soil was a fungus. And in that fungus was a molecule that would allow human surgeons to take the heart from one person and give it to another. To take an organ grown in one body, shaped by one life, one story, one set of memories, and give it a second life in another. To allow people to live who, without that small molecule from that quiet soil fungus, would have died. The history of medicine is, in no small way, the history of what we have learned from fungi. Let me tell you about one more medicine. It is not a conventional drug. It has a complicated legal history. But its story is one of the most remarkable in modern medicine. In 1958, a Swiss chemist named Albert Hofmann, the same man who had already accidentally discovered LSD, isolated a compound from a mushroom called Psilocybe mexicana. He called the compound psilocybin. The mushrooms from which it came were not new to the world. Indigenous cultures in Mexico and Central America. The Mazatec people, among others, had been using them in ceremony for centuries, perhaps millennia. They called the mushrooms tiananacatl, flesh of the gods. They were used for healing, for divination, for connection with the sacred. And then, in the 20th century, the Western world discovered them. And the story became complicated. Entangled with the counterculture of the 1960s, with fear, with prohibition, with decades in which scientific research was essentially forbidden. But in recent years, beginning roughly in the 2010s and accelerating dramatically through the 2020s, the research has resumed. And the findings have been, by any measure, extraordinary. Studies at Johns Hopkins University, at NYU, at Imperial College London and dozens of other institutions around the world have found that psilocybin, administered in a controlled, supported therapeutic setting, can produce profound and lasting relief from depression, anxiety, addiction, and the existential terror that so often accompanies a terminal diagnosis. One study found that a single guided psilocybin session produced the most significant reduction in depression scores ever recorded in a clinical trial. Another found that it helped lifelong smokers quit, with success rates dramatically higher than any existing treatment. Another found that cancer patients, facing death, reported after a single session a sustained transformation in their relationship to dying, a profound peace, a sense of connection, or reduction in fear that, in many cases, remained with them until the end. One participant described it afterward as this. She said it felt as though she had been given a chance to put down a weight she had been carrying for decades. A weight she hadn't even realized she was carrying. And she got up lighter. These are early days. The research is ongoing. The regulatory and ethical questions are complex. But something is happening. Something that began, as so much begins in the story of fungi, underground. In the quiet, patient, ancient knowledge of indigenous healers who knew, long before any laboratory existed, that the mushroom had something to teach us. If we were willing to listen. Let me take you back in time once more. Not as far this time. Not billions of years. Just about 10,000 years. To the beginning of what historians call the Neolithic Revolution, the shift from nomadic hunting and gathering to settled agriculture. To the moment when human beings, for the first time, began to deliberately grow their food. This transition, which happened independently in several places around the world, in the Fertile Crescent, in China, in the Americas, is considered one of the most transformative moments in human history. It changed everything. It led to settled villages, then towns, then cities. To specialization of labor. To trade, to writing, to all the structures we call civilization. And woven through this entire story, quietly, essentially, without much recognition, is fungi. Let's begin with bread. The ancient Egyptians, somewhere around 4,000 to 6,000 years ago, discovered something remarkable. If you left a mixture of grain and water out in the open air for a day or two, something happened to it. It bubbled. It rose. It became light and airy in a way that the original dense dough never was. What was happening, though they did not understand it in these terms, was fermentation. Wild Saccharomyces cerevisiae, yeast, floating invisibly in the air, had landed in the mixture and begun to eat the sugars in the grain. And as they ate, they produced carbon dioxide. Bubbles. Those bubbles, trapped in the gluten network of the dough, made it rise. When baked, the risen dough became bread, the lighter, airier, more digestible, more delicious bread, that would feed civilizations for millennia. The Egyptians did not know they were working with a fungus. They knew only that something magical happened to their dough when they left it out, and that if they saved a little of the old dough and mixed it into new dough. A practice called keeping a starter, they could transfer this magic from batch to batch. Some families kept their bread starters for generations. Some are kept for generations still. There are bakeries in San Francisco that claim their sourdough starters are over 100 years old, living cultures of yeast and bacteria, fed daily, cared for like a small, living pet, producing bread today that shares a direct biological lineage with bread baked in the 19th century. And then there is beer. Oh, the ancient, beautiful, deeply human story of beer. Evidence of beer brewing has been found in archaeological sites dating to at least 13,000 years ago, in the region of modern-day Israel and Jordan. Some researchers have suggested, controversially, that the desire to brew grain into beer may have been one of the motivating factors behind agriculture itself. That we didn't grow grain to make bread. We grew grain to make beer. And bread was the happy byproduct. Whether or not that is true, it speaks to how deeply fermentation and yeast have been wound into the human story from the very beginning. Beer kept people hydrated in a world where clean water was often scarce and dangerous. Beer provided calories. Beer lowered inhibitions, enabled socializing, and probably helped a great many anxious ancestors get through the night. Beer was used in religious rituals. It was used as currency. Workers building the pyramids of Giza were paid, in part, in beer. The workers who built one of the greatest wonders of the ancient world were compensated, in substantial measure, by a fungus. Now let's talk about cheese. Specifically, blue cheese. That sharp, pungent, magnificent creation, Roquefort, Stilton, Gorgonzola, with its distinctive blue-green veins running through the creamy white interior. Those veins are mold. Penicillium roqueforti, to be precise. A mold. A fungus. Deliberately introduced into the cheese during production, given space and air to grow, and left to do its work for weeks or months. As it grows, it produces enzymes that break down the proteins and fats in the cheese, creating the complex, intense, earthy flavor that blue cheese lovers adore. Legend, lovely, probably apocryphal legend, has it that blue cheese was discovered by accident. A shepherd in the caves near Roquefort-sur-Saulzon, in southern France, left his lunch, a piece of sheep's milk cheese, in a cave while he chased after a beautiful stranger. When he returned, weeks later, well, you can guess what he found. The cheese had not simply spoiled. It had been transformed. Shot through with blue-green mold. Pungent. Strange. Extraordinary. Whether he tasted it out of desperation or curiosity, we will never know. But he tasted it. And it was magnificent. And Roquefort was born. Today, Roquefort cheese, still made in those same caves, or caves very nearby, is protected by French law. Only cheese made in a specific way, in a specific region, using specific molds from those specific caves, can be called Roquefort. The caves themselves are considered essential to the product. They have a specific microclimate, temperature, humidity, airflow, that exists nowhere else. And in those caves, the mold has been growing, consistently, reliably, for at least several hundred years. Possibly longer. Those caves have been producing the same flavor, that sharp, rich, complex, ancient flavor, since before the printing press. Since before Columbus sailed. Since before Shakespeare wrote a single word. A fungus in a French cave, doing what it has always done, producing something beautiful. Without knowing it. Without needing to know it. Just doing its work. There is a role in the great story of life on Earth that is not glamorous. It is not celebrated. It is not featured in wildlife documentaries very often, because it does not involve speed, or drama, or the terrible beauty of predation. But without it, without this one role, all life on Earth would grind to a halt. The world would become buried beneath its own dead. The nutrients locked in every fallen tree, every dead animal, every shed leaf and dropped seed, they would stay locked, unavailable to new life, piling up century after century until the living world simply ran out of the raw materials it needs to continue. This role, the role of the decomposer, the recycler, the great dissolver, is filled, more than by any other kind of organism, by fungi. Imagine a massive oak tree. It has lived for 300 years. Its trunk is as wide as a car. Its canopy has sheltered generations of birds, squirrels, insects, and the occasional napping human. And now it has died. Perhaps a storm split it. Perhaps disease weakened it until it could no longer stand. It falls. And as it lies there in the forest, something begins. Within days, the first fungi are already at work. Their spores, microscopic, countless, drifting constantly through the air and soil, land on the moist, wounded wood. They germinate. They send threads, hyphae, into the wood. They begin to digest it. Not by chewing. Not by swallowing. Fungi feed differently than animals. They secrete enzymes directly into the material around them, breaking it down chemically, and then absorbing the dissolved nutrients through their cell walls. In a sense, they digest their food before they eat it. The world outside them is their stomach. And the wood of that oak tree, which is largely made of two extraordinarily tough compounds, cellulose and lignin, which almost nothing else can break down, is exactly what many wood-rotting fungi have evolved to consume. Some fungi break down the cellulose, leaving behind a red-brown, crumbling residue. This is called brown rot. Others, the white rot fungi, can break down even the lignin, the hardest component of wood, leaving behind a pale, fibrous, papery substance. Over months and years, the great oak is taken apart. Thread by thread. Molecule by molecule. The carbon locked in its wood is released back into the atmosphere. The nitrogen, the phosphorus, the minerals, they are freed from the wood and returned to the soil, where they will be taken up by roots. Where they will become part of new trees, new plants, new fungi. The carbon that was once that oak tree might, 100 years from now, be in the leaves of a maple, or the body of a deer, or the breath of a child running through a field. This is the great recycling. The endless turning of the wheel of matter. And fungi are its engine. Now here is a fact that carries a kind of deep time wonder with it. About 350 million years ago, trees evolved lignin. For about 60 million years after that, a geological period called the Carboniferous. It appears that no organism on Earth had yet evolved the ability to break lignin down. So the trees died. And nothing could decompose them. They piled up. Layer upon layer. Forest after forest, dying and falling and staying dead, accumulating over millions of years. Compressed by time and pressure and heat, this vast accumulation of undecomposed wood became something. It became coal. The coal that powered the Industrial Revolution. The coal that lit the furnaces that built the modern world. The coal that we have been burning for 2 centuries, releasing back into the atmosphere the carbon that was locked away during those 60 million years of fungal absence. At some point during the Carboniferous or slightly after, fungi evolved the enzymes capable of breaking down lignin. The great piles stopped growing. The carbon cycle resumed. But those 60 million years of accumulated dead wood became a fossil fuel that has shaped human civilization profoundly, and whose combustion is now reshaping Earth's climate. Our industrial story, our energy story, the story of why the air is warming, is, in a strange and winding way, the story of a gap in fungal evolution. Of 60 million years when the recyclers weren't ready yet. Everything is connected. The wheat in your bread and the coal in an old power plant. The oxygen in your lungs and the ancient wood at the bottom of a seam. The warming sky and a fungus that hadn't evolved yet when the Carboniferous trees were falling. Everything is connected. For as long as human beings have told stories around fires, fungi have been part of those stories. And perhaps it is not surprising. Mushrooms appear in places and in ways that seem designed to provoke wonder. They appear overnight. Where there was bare earth yesterday, suddenly there is a mushroom today, fully formed, seemingly from nowhere. They grow in circles. Perfect, uncanny circles in a field or forest, as if drawn by a compass, as if placed deliberately by something careful and precise. They glow in the dark. They cause visions. They kill. They heal. They feed, in strange and subtle ways, the oldest living networks on Earth. Is it any wonder that our ancestors, looking at all this, reached for the supernatural? Let's talk about fairy rings. Across Northern Europe, in England and Ireland and Scotland and Wales, and across Scandinavia and into Central Europe, the sudden appearance of a circle of mushrooms in a meadow was regarded for centuries as a deeply significant event. These were not random growths. These were, in the folklore of countless generations, the dancing floors of the fairies. The place where they came at night, invisible to human eyes, to dance and feast and conduct their mysterious business. A human who stumbled into a fairy ring, especially at night, was said to be in great peril. They might be pulled into the fairy world, trapped in endless dancing, losing all track of time. They might age rapidly, or find that years had passed in what felt like hours. They might be enchanted, confused, lost. The Welsh called the ring Cylchytwylwyth teg. The circle of the fair folk. The German tradition spoke of Hexenring, witch's ring. In France, they were Ronds de sorcières, sorcerers' circles. In many traditions, to destroy a fairy ring was to invite disaster. To walk around one 3 times at night was dangerous. To walk through one alone was to court madness. And to be generous to the idea, to not simply dismiss it as superstition, there is a logic in these warnings. Because fairy rings are, in a sense, magical. They are formed when a single fungus begins to grow outward from a central point, spreading its mycelium in an expanding ring. The mushrooms, the fruiting bodies, appear at the outer edge of this ring, where the growing mycelium meets fresh soil. The center is often a different color, sometimes darker, sometimes paler, because the fungus has already processed the soil there. The ring grows outward, year by year, at a steady rate. Some fairy rings in Europe are estimated to be hundreds of years old. The rings you might see today in an old meadow are the outer edge of a fungal organism that began growing in that place centuries ago. The fairies have been dancing there, in a sense, since before anyone alive can remember. Since before their grandparents' walked past and watched the circle grow. Since before the field had its current name. In Japan, the relationship with fungi has always been particularly intimate. Japanese culture has long celebrated matsutake, the pine mushroom, as a symbol of autumn, of transience, of the particular kind of beauty that exists because it is impermanent. The matsutake grows in old pine forests, increasingly rare forests, now, as urban expansion and monoculture forestry have changed the land. The mushroom is deeply seasonal. It appears for only a few weeks each autumn, fragrant with a scent that is extraordinarily complex, earthy, spicy, almost smoky, and then it is gone. In Japanese haiku, the matsutake appears as a symbol of this transience. In Japanese cuisine, a single matsutake, presented whole, grilled gently over charcoal, is a meal. Not a component. Not an ingredient. A meal in itself. To eat it is to eat the season. To taste autumn in a single bite. And the price reflects this. A single matsutake mushroom can sell for hundreds of dollars at peak season. But the price is not really the point. The point is the experience of something rare and brief and extraordinary. The point is the lesson that fungi, endlessly, seem to be teaching us. That the most precious things are often the most quiet. The most hidden. The most fleeting. That beauty lives not in permanence, but in the exact moment of its presence. There is a story I love. A real story, this one, about the truffle. The black truffle. Tuber melanosporum, the jewel of French cuisine. Truffles are the fruiting bodies of fungi that grow underground, entirely underground, pressed against the roots of oak and hazelnut trees, never seeing light. They are found by smell. For centuries, and in some places still today, pigs were used to hunt truffles. A trained sow would be led through an oak grove on a leash, and when she caught the scent, that extraordinary, deeply earthy, complex scent of a ripe truffle, she would begin to dig. The handler would then rush in, gently push the pig aside. The pig, being a pig, would very much like to eat the truffle, and carefully excavate the precious object. Why pigs? Because the black truffle, in order to attract animals who will disperse its spores, produces a compound that closely mimics the chemical that male pigs use to attract females. Androstenol. A pheromone. The truffle, with no brain, with no consciousness, with no understanding of pigs or desire or courtship, had evolved, over millennia, to produce a scent that would make a pig absolutely determined to find it. The fungus, underground and invisible, had figured out how to be irresistible. It had figured out how to be found. And we, as clever as we are, became part of the same strategy. We valued the truffle for reasons different from the pig. For the flavor, for the rarity, for the prestige. But we dug it up all the same. And in digging it up and moving it around, in carrying it from the forests of Perigord to the kitchens of Paris, we became, without intending to, the truffle's dispersal agents. The same role the pig was playing. The same role the forest creatures played before the pig was tamed. We thought we were hunting the truffle. All along, in some deep evolutionary sense, the truffle was hunting us. We have traveled a long way tonight, explorer. We have been to the beginning of life on Earth. We have walked through ancient forests and seen their hidden web. We have watched fungi make soil and bread and medicine and myth. Now let us walk toward the future. Because fungi, it turns out, may have a great deal to offer us in the years and decades to come. Let's start with something you might have heard about, mycelium as a building material. An American company called Ecovative Design has been pioneering the use of mycelium as a sustainable, biodegradable alternative to plastic foam, the kind of material used in packaging, in insulation, in countless industrial applications. The process is elegant. Agricultural waste, corn husks, hemp huds, wood chips, is mixed with fungal mycelium. The mycelium grows through the waste, binding it together with millions of interlocking threads. The result, after a few days of growth and then a drying process that stops the mycelium from fruiting, is a firm, lightweight, moldable material. You can grow it into any shape. You can grow it around fragile objects, creating custom packaging. You can grow it into bricks, into sheets, into insulating panels for buildings. And when you are done with it, when the packaging has served its purpose, when the building comes down, you bury it. Or compost it. Because mycelium packaging is completely biodegradable. It doesn't sit in a landfill for 500 years, slowly leaching chemicals into the soil and water. It goes back. It returns to the earth. It decomposes into nutrients. It does what fungi have always done. Several major companies are now using mycelium packaging. IKEA was an early adopter, replacing the polystyrene packaging of some products with mycelium-grown alternatives. Fashion has gotten involved too. Bolt threads and mycoworks are among the companies growing leather-like materials from mycelium, soft, durable, luxurious alternatives to animal leather that require no land clearing, no livestock, and no tanning chemicals. You can grow a jacket. You can grow a bag. You can grow the strap of a watch or the interior of a car door. From fungi. In a few days. From agricultural waste. Let's talk about plastic. There are an estimated 8.3 billion metric tons of plastic that have been produced since the material was first manufactured in the mid-20th century. Enormous amounts of this plastic are in the ocean. In the soil. Broken into microplastics so tiny they are now found inside human bodies, in our blood, in our lungs, in placentas. Plastic is one of the defining environmental challenges of our time. And it turns out that certain fungi may be able to help. In 2011, a group of Yale students on a research expedition to the Ecuadorian Amazon discovered a fungus called Pestilothiopsis microspora, growing, unremarkably, on the bark of a tree. When brought into the lab, this fungus demonstrated something extraordinary. It could eat polyurethane plastic. Not just degrade it slightly, over centuries, in the way all things eventually degrade. It could use it as its sole carbon source. As its food. It could digest polyurethane. Even in the absence of oxygen, conditions like those at the bottom of a landfill, converting it into organic compounds that could then be used by other life. Since that discovery, dozens of other plastic-eating fungi have been identified. Aspergillus tubangensis, found in a landfill in Pakistan, was found capable of breaking down polyurethane in just a matter of weeks. Research is ongoing. Scaling these processes up, making them practical, understanding the chemistry well enough to deploy it reliably, is a long and difficult task. But the fungi are there. They have, as they always seem to, already evolved a solution. We just need to learn to work with them. There is one more frontier I want to visit tonight. It is perhaps the most personal. And it begins in the brain. Researchers studying psilocybin. The compound from magic mushrooms that we discussed earlier, have made a fascinating discovery about how it works in the human brain. When psilocybin is active, the brain enters a state of dramatically increased connectivity. Regions of the brain that do not normally communicate with each other begin to talk. The default mode network. The part of the brain responsible for the ongoing narrative we tell ourselves about who we are, the inner voice, the constant self-referential chatter, becomes quieter. And in that quietness, in that expanded connectivity, something can happen. New perspectives emerge. Old patterns loosen their grip. The fixed, rigid, often painful stories we carry about ourselves and the world become, at least temporarily, more fluid. There is a term neuroscientists have used for this. Neuroplasticity. The brain becomes more plastic, more changeable, more open to new patterns, more capable of learning new ways of being. And what is neuroplasticity, in its deepest sense, but the brain's capacity to grow? To change? To heal? There is something poetic, something almost unbearably resonant, about the idea that a compound produced by a mushroom might help free the human mind from its own loops. That the same kingdom that breaks down dead matter and recycles it into new life, that decomposes old wood into new soil, might help us decompose old patterns of thought into new possibilities for being. That the great recyclers of the earth might be, in some small way, helpers in the recycling of the self. I don't want to over-romanticize this. The science is early. The ethics are complex. The applications are carefully controlled and supervised. But the direction is extraordinary. And the fact that we are here, at the intersection of ancient indigenous knowledge, cutting-edge neuroscience, and a small organism that has been on Earth for 1 billion years, feels like something worth sitting with. Worth reflecting on. Worth carrying gently, like a question rather than an answer, into sleep. Let me tell you how mushrooms are born. Not in the way of animals, or plants, or anything you have likely thought about the birth of living things before. Let's start underground. The mycelium, that vast, thread-like web we have visited several times tonight, grows through the soil, through wood, through whatever substrate the fungus calls home. It grows steadily, exploring, absorbing nutrients, mapping its environment one hyphal thread at a time. And at some point, the conditions are right. The moisture is correct. The temperature is correct. Perhaps the season has shifted, autumn approaching, or spring arriving, or the first rains of the monsoon soaking the dry earth. Something signals to the mycelium, now. And the mycelium responds. It begins to concentrate energy and material at certain points. Tiny knots of hyphae form, almost invisible, barely distinguishable from the surrounding mycelium. These are called primordia. The beginnings. The seeds, in a sense, of what will become a mushroom. Over hours, sometimes just hours, the primordium grows. It draws water from the mycelium. It expands and differentiates, different cells become different parts, the cap beginning to distinguish itself from the stem, the gills beginning to form. And then, in the space of a night, sometimes literally overnight, it pushes up through the soil. The mushroom emerges. Fully formed. Complete. This is why mushrooms appear to arrive from nowhere. Because they do. The preparation happens entirely underground, in darkness, invisibly. And then, in what feels like an instant, there it is. Small and perfectly formed, covered sometimes in the remnants of a membrane that protected it as it grew, the veil, which tears as the cap expands, leaving a ring of tissue on the stem, called an annulus. On some species, the young mushroom is entirely enclosed in a universal veil, a complete wrapping of tissue. As it grows, this tears, and the base of the stem is left wearing what looks like a small cup, the vulva. The Amanita mushrooms, including both deadly species and the famous fly agaric, have this arrangement. The white spots on the red cap of Amanita muscaria are the remnants of this universal veil, left behind as the cap expands. The mushroom, in a sense, is born wearing its birth caul. Still carrying the evidence of how it arrived. Now the mushroom has a purpose. It needs to spread spores. And it needs to do this before it is eaten, before it rots, before the brief window of its fruiting is over. The gills beneath the cap, those fine, close-packed sheets of tissue, are lined with billions of microscopic spores. And mushrooms have evolved an extraordinary range of strategies for getting those spores into the air and the world. The most common is simple: the spores are ejected from the gill surface, fall through the gap between the gills, and are caught by the slightest air current. Some species do this with mechanical precision. High-speed photography has captured spores being fired from the gill surface at tens of thousands of times the force of gravity. Among the fastest known biological launches. Then there are the puffballs, round, pale, often coconut-sized fungi that build up their spores inside a papery outer skin. When the skin is breached, by a falling raindrop, a passing animal, a curious human pressing a finger against it, the spores erupt in a cloud. A visible, billowing cloud that can contain trillions of microscopic bodies. Trillions. In a single puff. Across a large forest, in autumn, the total quantity of fungal spores in the air is almost incomprehensible. It has been estimated that in a single season, a single square meter of boreal forest floor can release billions of spores into the air above. These spores are carried by wind, sometimes hundreds of miles. Sometimes thousands. Fungal spores have been found at the top of Everest. In the stratosphere. In air samples collected over the middle of the Atlantic Ocean. The Earth is wrapped in a thin, invisible, constantly circulating cloud of fungal spores. And every one of them is a tiny, patient, extraordinary potential. Waiting. For the right substrate. For the right moisture. For the right temperature. For the conditions to be right. And when they are, the mycelium begins. The web begins. The long, quiet, patient work begins again. As it has been beginning, on this earth, for over 1 billion years. Not all mushrooms are safe. Let me be very clear about this. In a story that has celebrated fungi so thoroughly, that has rhapsodized about their beauty and their intelligence and their generosity, it would be irresponsible not to sit with this fact clearly. Some mushrooms will kill you. And not quickly. Not kindly. Some of the deadliest mushrooms on Earth are also among the most beautiful. The death cap. It is responsible for approximately 90% of all fatal mushroom poisonings worldwide. It is a pale, yellowish-green mushroom, sometimes almost white, with a pleasant smell and a taste that is not, according to those who have eaten it accidentally, particularly alarming before the consequences make themselves known. It grows commonly alongside oak, chestnut, and other broadleaf trees across Europe and, now, in North America, where it was accidentally introduced with European trees in the 20th century. The danger of the death cap is profound not because of its immediate effect, but because of its delayed one. When you eat it, nothing happens. Not immediately. Not for 6 to 24 hours. You feel fine. You might feel slightly off, but nothing alarming. And then, the symptoms begin. The toxin, amatoxin, has been quietly at work in your liver and kidneys. It is one of the most potent natural toxins known. A single cap, a single mushroom, contains enough amatoxin to kill a healthy adult. The stories of accidental death cap poisonings are heartbreaking. Many involve immigrants and refugees who have foraged mushrooms in their home countries for generations, who recognize mushrooms that look similar to edible species they know well, but are not. The death cap is a European species that looks, to the untrained, like the paddy straw mushroom, Volvariella vulvacea, which is widely eaten and deeply beloved in many Asian cuisines. People forage in California or Australia or the UK, finding what they believe they recognize. And they are wrong. And the consequences are devastating. This is not a story told to frighten you. It is a story told in respect. The same kingdom that feeds us, heals us, connects us, and sustains us is also a kingdom that demands our attention and our humility. A kingdom that does not tolerate carelessness. Never forage for wild mushrooms unless you are absolutely certain of your identification, or are with an expert who is. The beauty is real. The danger is real. But alongside the deadly, there is the divine. And here I want to speak, gently, carefully, about the mushrooms that produce psilocybin. There are hundreds of species that produce this compound. They grow on every inhabited continent. They grow in meadows and on compost, in tropical forests and in temperate woodlands. Some are tiny and drab, easy to overlook. Some are slightly more striking. None of them announce themselves. None of them bear warning signs that say, "I will change your mind." The Mazatec Curandra, Maria Sabina, one of the most important figures in the history of sacred mushroom traditions, described the mushrooms as children. She called them the Niños Santos, the holy children. She used them in all-night healing ceremonies called veladas, watchings, in which she would eat the mushrooms, enter an altered state, and spend the night singing, praying, and conducting a kind of healing dialogue between the ordinary world and the sacred one. In 1955, an American banker named R. Gordon Wasson attended one of these ceremonies. He was the first outsider, the first non-indigenous person, to be permitted to participate. And in 1957, he wrote about it in Life magazine. It was one of the most widely read magazine articles in American history. It set off a cascade of interest, scientific, artistic, spiritual, that would shape the counterculture of the 1960s, eventually lead to a crackdown and decades of prohibition, and ultimately seed the renaissance of psychedelic research that is now transforming psychiatry. All from one banker in a village in Oaxaca, Mexico. All from one healing ceremony. All from a small, quiet, dark mushroom growing on the side of a mountain. Maria Sabina, when she learned what Wasson's article had unleashed, the floods of foreign seekers coming to her village, the disruption to her community, the trivialization of something sacred, reportedly said that the mushrooms had lost their power when their secrets were revealed to the world. Whether she was right about that in a literal sense, whether the mushrooms lost some quality, is not for me to say. But she was right in the sense that something was lost. The context. The sacredness. The relationship. The mushrooms, taken from their cultural and spiritual home, used by thousands of curious Westerners without ceremony or guidance or understanding, became something different from what they were in a velada in Oaxaca. This is a lesson worth carrying. That the power of a thing is always bound up with the context in which it is held. That the same substance can be medicine or disturbance depending on how it is approached. That everything, even something as small and quiet as a mushroom, deserves to be met with respect. There is something I want to explore with you in this deep, quiet hour. Something that might seem strange in a story about mushrooms. But I think it belongs here. Let's talk about death. Not in a frightening way. In the way that the forest talks about death. Which is to say, with complete, unhurried, matter-of-fact tenderness. In the forest, death is not an ending. This is not a metaphor. It is not a spiritual consolation. It is a biological fact. When a tree dies in an old-growth forest, it does not disappear. It becomes something else. It becomes a snag, a standing dead tree, which is home to woodpeckers and owls and dozens of species of insects and fungi. It falls. And becomes a nurse log. A rotting trunk on the forest floor, so rich in nutrients that other trees take root in it, grow from it, are literally born from it. Walk in an old enough forest and you will see rows of trees, perfectly spaced, perfectly aligned, growing from an invisible line where a log once lay and was gradually dissolved, over decades, by fungi. The trees growing from it owe their existence to the death of the tree before them. The fungi owe their presence to the wood that feeds them. The soil owes its richness to everything that has died and been returned. Death, in the forest, is the engine of life. It is not the opposite of life. It is part of the same cycle. Part of the same breath. There is a movement in human death care, small now, but growing, that is drawing on this understanding. Natural burial. The practice of being buried without embalming, without a metal casket lined with non-biodegradable materials, but simply wrapped in a shroud or placed in a plain wooden box, in soil where the body can decompose naturally. Where fungi can do what fungi do. And there is a more recent, more dramatic version of this, developed by an artist named J. Rim Lee. She has created what she calls the infinity burial suit. A garment, to be worn in death, that is embedded with mycelium. Fungi specifically chosen for their ability to decompose human remains and neutralize the toxins that accumulate in human bodies over a lifetime of exposure to pollution, pesticides, and preservatives. The idea is that the mycelium will consume the body, break down its toxins, and return its nutrients, clean, safe, useful, to the soil. That you might, in some small way, become part of the web. Part of the network that feeds the trees. Part of the recycling that has been going on since before there were humans to die in it. I find this idea, genuinely and simply, beautiful. Not morbid. Not frightening. Beautiful. The idea that at the end of a life, after all the struggles and joys and ordinary days and extraordinary moments, you would return. Not to emptiness. Not to nothing. But to the web. To the mycelium. To the soil. To the trees. To the quiet, continuous, patient work of life feeding life. There is a philosophy in this. A philosophy that the forest has been practicing for 470 million years, long before any philosopher sat down to put it into words. Nothing is wasted. Nothing is lost. Everything returns. Everything becomes part of what comes next. You are made of everything that has come before you. And everything you are will, in time, become part of everything that comes after. The fungus knows this. The mycelium knows this. The forest knows this in every one of its threads. And perhaps, in the quiet of this dark hour, you can know it too. Before I let you rest tonight, I want to take you on one final small walk. Not a grand journey through time and science. Just a walk. It is early morning. The light is that particular quality of morning light, pale and gold and horizontal, coming through trees, picking out every dewdrop, every spider's web, every small wet thing with extraordinary clarity. The air is cool. Your breath makes small clouds. You are walking in a park, or a forest, or along the edge of a meadow, somewhere green, somewhere where things grow in their own time without asking permission. And as you walk, you begin to pay attention to what is underfoot. Not the grand dramatic features. Not the big trees or the distant hills. Just what is immediately beneath you. Here, A small cluster of pale mushrooms growing from a patch of leaf litter. Tiny things. You might have stepped over them without noticing. But you look. They are translucent almost. In the morning light, you can see the pale yellow of the cap almost glowing. Their stems are thin and delicate, like threads of white glass. They have been here since last night, erupted in the darkness, while you were sleeping, from a mycelium that has been quietly building for years in this patch of earth. They will be gone in a few days. Maybe fewer. But right now, they are extraordinary. Further along, you find something different. A large, flat bracket fungus on a fallen oak. It has been growing here for years, you can tell by its concentric rings, each one representing a season of growth. The surface is a rich chestnut brown on top, cream white below. Touch the underside, gently, and you will feel thousands of tiny pores, the openings of the tubes through which its spores are produced. This fungus is consuming the wood it sits on. It is, in the language of ecology, a decomposer. But in the language of the forest, it is something else. It is the transformer. The returner. The one that makes new soil from old wood. The one that makes the next generation possible. A few steps further, a circle. A fairy ring. Small mushrooms, evenly spaced, in a near-perfect circle perhaps 2 meters across. The grass inside the ring is a slightly different shade of green. The mycelium has changed the soil chemistry here, given it something extra, taken something away. The ring is real. It is physical. It is the outer edge of a single organism, spreading outward as it has been spreading for, who knows? Decades? Longer? You stand at the edge of it and you feel, just for a moment, that frisson of old wonder. The same wonder that made your ancestors call it a fairy ring. The same wonder that made them tell stories about what danced here at midnight. You are not superstitious. You are rational. You know what this is, biologically. And yet the wonder remains. Because knowing what something is, having the words, the science, the taxonomy, does not diminish its strangeness. If anything, it deepens it. Because the truth of a fairy ring. The truth of a single organism spreading outward across decades, growing in a perfect expanding circle, connecting tree roots and feeding birds and decomposing leaves and making soil, is stranger and more wonderful than the fairy story. The science does not explain away the magic. The science is the magic.